Hello, what is up everybody? This is Devyan and welcome back to my channel Learnium, where we learn and discuss with a lot of fun. So this is our next part of our learning journey of electricity, right? So till now we have discussed about the current and the voltage, right? But now let's say that if I were to tell you that in our circuit there is some voltage, let's say 12 volts, right? The voltage is 12 volts. Now after knowing simply that, will you be able to tell me what is the current? By the way, right now I don't think that you can, because in order to do that we first need to find some relationship between the voltage and the current, and that is what we are going to do in this video. So let's begin this. The relationship, right, between the voltage and the current is given by Ohm's law. By the way, I am saying that Ohm's law, like, it's not a law, it was just an observation made by him. By the way, observation made by George Ohm, but he was the first person to make that observation, so we give him credit. So that's why today we call it as a Ohm's law. So let's see what Ohm's law was. So here we have a very simple looking circuit. We have one battery. By the way, here we have a variable battery. Variable means that we can change the voltage according to us, right? By the way, this was also called as eliminator, right? This device is also called as eliminator, right? So here we have one eliminator, one voltmeter, ammeter, a switch, and also one bulb, right? And after that we have a wire which is connecting all our elements together, right? So that is very clear. Now what we are going to do? So at every time we will change the voltage, right? And we will write down the readings of the voltmeter and ammeter in our copy. By the way, voltmeter is a device, yes, which is used to measure the voltage, and ammeter is used to measure the current, right? So whenever we will change the voltage, we will write down the readings of the voltmeter and ammeter, and then after that we will try to find some relationship between the voltage and the current. So let's do that. Okay, so now let's put our voltage at 6 volt, right? So what we have to do, write down the readings of voltmeter and ammeter. So voltmeter is showing 6 volt and ammeter is showing 1.5 ampere, right? Now first of all, turn off the switch, then you can change the voltage, then again turn on the switch, and after that again write the readings. Now we have 10 volts as the voltage and 2.5 ampere as the current, right? So now we can change it again, and now we have 12 volts and 3 ampere, right? So that's it. Now we can move the circuit aside, right? So here we have one simple table which gives the readings of voltmeter and ammeter. Now can you see some relationship between the voltage and the current, right? So now first of all, let's try to draw a graph with this data or with this information. And what you get? Yes, we got a simple straight line, right? So what it shows? It shows that voltage and the current are directly proportional to each other. It means that whenever the voltage goes up, the current also increases, right? And vice versa. When voltage increases, current increases. When voltage decreases, current also decreases, right? So here we got one relationship, that voltage is directly proportional to the current, right? So V is proportional to I, directly proportional to I. Now what it means? It means that voltage is equals to current multiplied by some constant, right? Some constant. Now we are going to find that what is that constant and what is the value of that constant. So that constant is resistance. Yes, a new word for you. By the way, it is very simple. We will cover more about it in our next video. But right now, if I were to tell you in brief. So when you heard the word resistance, what comes in your mind? Hey, resistance, to resist something, to stop something. So what we are trying to stop here? we are trying to stop the current, right? A lot of current coming in and we are trying to stop it. That is simply the resistance. So now resistance, like it is useful in some places, but in other places it is not useful, right? So we will cover more about it in our next video. So resistance is denoted by a capital R and its unit is ohm, right? So can you relate? Like we have Ohm's law, like named after George Ohm, and now we have ohms, the unit of resistance, right? So we have V is equals to I into R, like V is equals to IR. Voltage is equals to current into resistance, right? So now instead of this, we can also write the units here. So 1 volt is 1 ampere into 1 ohm, right? So that is very clear. And now if you were to rearrange the terms here, what we get? Yes, 1 ohm is equals to 1 volt by 1 ampere. It means that when 1 ampere of current passes through a conductor at a potential difference of 1 volt, then our resistance is 1 ohm, right? That is very easy, right? So once we are done with that, now we can bring in the data which we saw earlier in this video, right? So here we have this table. Now what we can do, we will try to plug in the value here. So we have voltage 12 volts, that is equals to current, which is 3 ampere multiplied by resistance. So from this we can find out the value of resistance. So now what is the value of resistance here? Yes, it is 4, and by the way 4 ohm, right? Ohm is the unit of resistance, right? So that was simply Ohm's law, but there are a few more things which we are going to explore in this video, right? So we have V is equals to IR, but from this what we can make one more relationship. So if we were to rearrange the terms here, we will get R is equals to V by I. What it gives us? It gives us that R, or the resistance, is inversely proportional to the current. It means that if you increase the resistance, the current will decrease and vice versa. Now one more thing I would like to tell you is that in our real world, almost everything has some resistance, right? Everything has some resistance. Now the materials which have low resistance, right? It means that they don't have much problem with the flow of the current, right? So which have low resistance, it means that they are conducting more. So that is why we call them good conductors of electricity. And all the metals are the good conductors of electricity. Now we can do the opposite of it, right? The materials which resist more, which have high resistance, it means they are conducting less. So we call them insulators. By the way, they were earlier called insulators. Today we call them bad conductors. But why? So after when we find out that the materials which we call as insulators, even they can conduct electricity in the extreme conditions of temperatures and pressure. For example, air. So air was thought to be as an insulator, but after some time we find out that even air can conduct electricity in the extreme conditions of temperatures and pressure, right? Lightning, we all know that air conducts electricity between the cloud and the earth, right? So that is the reason we don't call them insulators. By the way, we call them bad conductors. So we have good conductors and we have bad conductors. So here we have metals and here we usually have non-metals. So that is very clear. Now, since we know that everything has some resistance, it means that the wire, like in our circuit, they will also have some resistance. But the thing is that while we draw the diagram of circuit or while we solve these problems in a notebook, we usually make one assumption. What is that? We assume that the wires have zero resistance, right? So we assume that the wires which are connecting all the elements, they have zero resistance. But in real life, they have resistance, like they do resist the flow of charges. So that is the thing which we have to keep in our mind. Now one more thing, that the resistance of a material also changes on different conditions, which we will cover in our next video. But right now I would like to tell you that when we were doing about the Ohm's law, right, when we were observing or we were trying to find out some relationship between the current and the voltage, right? So in that case, our temperature should be same, right? So if you will do that in different temperatures, our values will also get changed, right? So you will understand what it really means, right, when I'm saying that temperature changes the resistance. So we will cover that in our next video, right? So for this we have done a great job, right? So I hope that you understood this, and now I will meet you in our next video. Thank you very much for watching.